I want to write a function to find the exponent of a number. This problem is easy to solve using recursion because in general x to the power n is equal to x times x to the power n minus 1, right? So 2 to the power 6, for example, would be 2 times 2 to the power 5. Whenever we think about recursion, we also have to worry about the base case, which is the simplest problem that cannot be reduced any further. It's also when recursion stops happening. In this case, the base case is when n is equal to 1. When n is 1, x to the power n is just x. So let's write the function. I'm going to call the function power. It's going to take in two variables, x and n, and it's going to return an integer. Let's first implement the base case. That's when n is equal to 1. When n is 1, we want to just return x. Otherwise, we want to return x times x to the power n minus 1. And just like that, we've written a function to find the exponent of a number. We can test this. Let's test it with 2 to the power 4, which should be 16. Yep, it is 16. So this program works. Now I'm going to write a function that's iteratively going to compute the exponent of a number. So I'm going to create the function. It's going to be called power_it because the function power already exists. It's going to take in two variables, x and n, and return a number. So for this function, I'm going to have to create a variable called power, set it to be 1, and then with a for loop, I'm going to multiply x by itself n times. So the code looks something like this. We're going to set power to be power times x, and then we're going to return power. Which function do you think is better? If you analyze them, both will take the same number of steps, and this function is clearly much harder to write than this. So does that mean recursion is better? Still no. So I'm going to add a breakpoint here, and then we're going to analyze the function with the debugger. So I'm going to ask the iterative function to give me 2 to the power 5, and we're going to see how it does that. So right here in the call stack, there's one function, and because it's iteration, there's always going to be one function, and there are 4 local variables in that function. Now as we step into the function, these variables are going to change, and finally it's going to give us the answer. So that's 32. Now if we move the breakpoint to the recursive function and then run that, let's see what happens. I'm going to ask the recursive function to give me 2 to the power 5. Right now there's one function in the call stack, and there are two variables in that function. And as I step into the function, what you'll see is happening is more functions get stacked onto the call stack, and each of them have two variables. So at this point, Java is keeping track of 8 variables, and if you had a larger input, it could be keeping track of thousands of variables. Whereas with iteration, you're only keeping track of 4 variables throughout the program. So this is why iteration is better. Even though both recursion and iteration are going to take the same amount of time, recursion is always going to take more memory for large inputs because the functions get stacked on top of one another, and Java has to keep track of the variables of each function. So if your call stack had 1,000 functions and each function had 10 variables, then you'd have to keep track of 10,000 variables. Whereas in iteration, even if you did the same thing 1,000 times, Java would only be keeping track of 10 variables. So this is why iteration is better.